So in this lesson, we're going to learn how to do integration with log functions and ln functions. Most of these examples are no different than doing integration by substitution. You just have to recognize the pattern for integration by substitution. So in the first example, the 2 is a constant. So I'm going to bring it outside the integral. 1 over x dx, and then you need to think about what function gives you a derivative of 1 over x, and we know that if our function is ln x, my derivative is 1 over x. So if I was going to do the integral of 1 over x, you get ln x, but here you have to be careful because this function had a domain of all real numbers. So I want to make sure that my integral also has a domain of all real numbers except 0. So I need to make sure I put an absolute value of x plus my arbitrary constant because this is a indefinite integral. So basically the rule states that when we're doing the integral of 1 over x dx, we need to do the ln of the absolute value of x plus my arbitrary constant. Again, the domain of both functions are x cannot equal 0. If I have sort of some, like a 1 over u du, same thing, they've just changed the variable on us. The integral would be ln of absolute value of u plus c. So here, now there's a little bit of chain rule. What we want to think of is this is 1 over something. So what I'm going to do is, what is the derivative of the something? So 4x minus 1, the derivative is 4, which is just a number, so that's okay. So I'm going to introduce a 4 on the top and a 4 on the bottom. My derivative is du dx is 4. So my du term is equal to 4 dx. So in my integral, the 4 and the dx will turn into du. The 4x minus 1 will turn into u, and I'm ready to do integration by substitution. So there's this 1/4 left on the outside. My integral will become 1 over u, and then du. So the integral of 1 over u is ln of absolute value of u. My 1/4 gets carried forward on the outside, plus my arbitrary constant I add on. Now, again, you have to remember my original question was in x's, so I need to make sure my answer has x's in it. My u is equal to 4x minus 1, so I sub that back in, and there's my answer. We're going to move into finding areas under curves as well. Now, the area under the curve is still sort of the integral. We talked about how to do the area under the curve. So the first thing you want to do is figure out what the graph of x divided by x squared plus 1 looks like. And so I'm just going to pull up that graph here for you guys. So you would have to know what this graph looks like. You could do a table of values, or later on you can use the ideas we learned in curve sketching to do the graph. You're going to get some graph that looks something like this. And the x-axis, which I'm going to draw in orange, and the line x equals 3. So the bump happens at 1, so let's say x equals 3 is somewhere about there, and then we're looking for this area under the curve. So we use an integral to set up that area under the curve. So the integral from 0 to 3 of my function, which is x over x squared plus 1 dx. And now when I look at this to solve this problem, the integral is integration by substitution because the derivative of x squared plus 1 is 2x. So if I let u equal x squared plus 1, my derivative term is 2x. So I'm missing a 2. I'm going to introduce a 2 on the top, a 2 on the bottom. You can introduce it either on the inside or the outside of that integral. So my du is equal to 2x dx. I'm going to highlight that in orange. So there's the 2, the x, and the dx. My u was x squared plus 1. And now I need to change my integration limits. These are x values. So if x is equal to 0, u is equal to 0 squared plus 1, which is 1. And if x is equal to 3, u is equal to 3 squared plus 1, which is 10. So those are going to become my new lower and upper limits of integration. So I'm going to replace this integral. This 2 on the bottom has not got dealt with, so I need to carry that through in my integral. The 0 to 3 became a 1 to 10. The x dx and the 2 became a du. And this became 1 over u. Now this is a definite integral, so I'm going to do the integral. I don't need my plus c. Ln of absolute value of u, we're going to evaluate that from 1 to 10. So this is 1/2 ln 10. I dropped the absolute value because 10 is positive anyways. Minus 1/2 ln 1. And we know that ln of 1 is, ln 1 is positive, so I can drop the absolute value. Ln of 1 is 0, so this just simplifies to 1/2 ln of 10. So this value represents that area in red under the curve. Now, again, we're going to continue using integration by substitution to recognize this new formula that we're learning up here in orange. So I take the derivative of the bottom, 3x squared plus 1. I notice that that derivative is on the numerator, so I'm ready to do integration by substitution. I'm going to let u equal 3x squared plus 1. Whoops, not 3x squared plus 1. X cubed plus x. My derivative term, du dx, is 3x squared plus 1. I'm automatically going to multiply the dx to the other side. So now my integral would become, the u becomes on the denominator. The x squared plus 1 dx becomes the stuff on the numerator, which is a 1 du. I integrate ln of absolute value of u. This is an indefinite integral, so I need my plus c. I replace my u back with x cubed plus x. Again, you can always take the derivative of your answer to make sure you've done the question correctly. In this example, u is equal to tan x. I know that the derivative of tan x is sec squared x. I'm automatically going to multiply the dx on the other side. This integral will turn into 1 over u du, just like the previous example, which is ln of absolute value of u plus c, and then I sub my u back in. So what you're going to notice is that the derivative of the top is the derivative of the bottom is found exactly on the top, so that the integral just becomes ln of that denominator term, because the derivative would kind of cancel out when you do chain rule anyways. Now this one, we have extra stuff happening. If u is equal to x squared plus 2x, my derivative term would be 2x plus 2, and you're noticing that I'm missing a 2 on this entire numerator, or you can look at it as 2 bracket x plus 1, so I'm missing that extra 2 out front, so I'm going to introduce the 2 on the top and the bottom. So the 2x dx becomes du, so 2x plus 1 dx becomes du. The u term is found on the denominator, and then that extra 1/2 is floating out front. So 1/2, 1 over u du. So 1/2 ln of absolute value of u plus c. And then I sub my u back in, ln x cubed plus x plus my arbitrary constant. In this example, u would be 3x plus 2. My derivative is 3, and I multiply the dx on both sides. You can see I'm missing the 3. I'll introduce it on top and bottom. You can introduce it either on the inside or the outside of the integral, so 3 dx. My u term is found on the denominator. This integral will become 1/3 1 over u du. And then again, the integral of 1 over u is ln of absolute value of u plus c. And I go ahead and I sub my u back in, which is 3x plus 2. So we're just pretty much doing integration by substitution in different examples to recognize this main rule, which is kind of the lesson that we're presenting here. Now, in some examples, you may have to do long division before integrating. So this is one of those examples. Now, sometimes we've talked about in 30-1 where we don't need to use long division because of synthetic division, but because this is a quadratic factor, we do need to do long division.